Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rogini College of Engineering and Technology. I am going to handle the subject on Communication Engineering. So now I am going to discuss about the topic on Amplitude Modulation. First, we have to know what is meant by Amplitude Modulation. So on completion, the students will be able to what is modulation, what is meant by amplitude modulation, define modulation index. So first, what is meant by modulation? So the modulation, this is the process, some characteristics of a high frequency carrier signal, that is we have to take the band pass signal. This will be changing the instantaneous amplitude of the information signal, that is baseband signal. So this process will be called as modulation. So why we have to use the modulation? This will be mainly suitable for signal transmission. So for distance we have to use. So the multiple signal were transmitted on the same channel. Capacitive or inductive devices, this will be may require high frequency input that we have to need to operate. Then the stability and noise rejection. So about modulation, we have to know the application. So this will be mainly used for the broadcasting of both audio and video signals, mobile radio communication such as cell phone. So what are the basic modulation techniques we are using? One is amplitude modulation. This will be changes based on amplitude. Next, frequency modulation. This will be mainly changes the frequency. Then phase modulation. This will be mainly changes the phase. Then in this communication technique, we are having one source, then transmitter, then we are having the transmission channel, then receiver, and finally we are having the destination. So the communication, we are having two types of communication. One is analog communication, another one is digital communication. So in this analog communication, we have to transmit the information. This will be in the form of continuous in nature. Whereas the digital communication, this is discrete in nature. So we are having the block diagram. So in that thing, the information from the source should be modulated before the transmission. This should be enable the proper transmission of information from transmitter to receiver. So this process is modifying or changing any characteristics of any signal. This will be called as modulation. So the particular signal will be having three characteristics. One is amplitude modulation, frequency modulation, and phase modulation. So amplitude modulation means, so this is the simplest and the earliest form of transmitters. So whereas the information signal, this will be varies that instantaneous amplitude of the carrier. So this is the modulating signal, then this is the carrier signal. Finally we are having the modulator signal. This is the output signal. So the amplitude modulation, this is the process by which the amplitude of the carrier is varied in accordance with the amplitude of the modulated signal, but the frequency and phase of the carrier, this will be constant. Then we have to see the mathematical representation of AM. So where Vam of t will be equal to Vc into 1 plus Ma sin 2 pi Fmt into sin 2 pi Fct. So Vam of t will be equal to, so we have to multiply the Vc in the bracket term. So Vc sin 2 pi Fct plus Vc Ma sin 2 pi Fmt into sin 2 pi Fct. So next we have to substitute the formula for sin A sin b, that is 2 sin a sin b will be equal to cos a minus b minus cos a plus b. So now we have to apply that formula in that before equation. So VAM of t will be equal to VC sin 2 pi FCT plus VC MA divided by 2 cos 2 pi into FC minus FM of t minus cos 2 pi FC plus FM of t. So finally we will get the equation like this, that is VAM of t will be equal to VC sin 2 pi FCT plus we have to multiply the VC into MA divided by 2 in the bracket term. So finally we will get VC into MA divided by 2 into cos 2 pi FC minus FM into t minus VC into MA divided by 2 cos 2 pi FC plus FM of t. This is the mathematical representation of amplitude modulation. Then we have to calculate the modulation index. So how we are calculating the modulation index means this is the ratio of amplitude of the message signal to the amplitude of carrier signal. So this will be called as the modulation index, otherwise then we will call it as modulation factor or depth of modulation. So next one we are having the percentage of modulation. So if the modulation is expressed in percentage, then we will call it as this is the percentage of modulation. So in the amplitude modulation, this will be contain full carrier and upper sideband and the lower sideband carrier. So we will call it as double sideband full carrier. Then how we have to calculate the bandwidth. So the bandwidth of the signal will be contained by taking the difference between highest and the lowest frequency. So in that way we have to calculate the bandwidth. So that is upper sideband frequency minus lower sideband frequency will be equal to bandwidth. So for example, upper sideband we are having FC plus FM and lower sideband FC minus FM. So finally we have to calculate the bandwidth, that is 2 into FM. So the bandwidth of the AM signal is twice of the maximum frequency of modulating signal. Then sidebands. We are having two sidebands, one is upper sideband frequency, another one is lower sideband frequency. So upper sideband frequency will be equal to FC plus FM, then lower sideband frequency will be equal to FC minus FM. Phasor or vector representation of AM. The phasor for upper sideband rotate in anti-clockwise at an angular frequency of omega m. So the lower sideband, this will be rotate in clockwise direction. This will be having the same angular frequency of omega m. So the upper and the lower sideband frequency we have to calculate. So the upper sideband frequency, this will be rotate faster than the carrier, that is omega m will be greater than omega c. Then in lower sideband frequency, this will be rotate slower than the carrier, that is omega m less than omega c, where MA is the modulation index. Percentage of MA, this will be equal to percentage of modulation index. So if you are having two or more signal, we have to modulate these two signals by a single carrier. The modulation index will be equal to root of m1 square plus m2 square. So MA is the total resultants modulation index. M1 and M2, these are the modulation indices due to individual modulating components. Upper sideband voltage will be equal to EC into MA divided by 2, then lower sideband voltage will be equal to EC into MA divided by 2, where critical modulation MA equal to 1. So next we have to find the VSB will be equal to USB will be equal to VLSB, that will be equal to EC divided by 2, that will be equal to Vmax plus V minimum divided by 2 into 2. So Vmax plus V minimum divided by 4. This is the upper sideband and the lower sideband voltage. So the quiz question is based on the amplitude modulation is a type of amplitude modulation in which carrier is suppressed is called dash. Thank you.